So I'm going to save us some time on these first few because, do these look like, well, let me ask you this. When you first look at these, do they look like inverses? Let's think about, never really done this before, but let's think about f of x. If we were going through order of operations, what would be if we knew an x value and we were going to plug it in, what's the first thing we would do to it, Lucas K? Okay, so you'd first multiply by 3, then you would, keep going, Lucas. Add 7, and then you would divide by 2. If you look at g of x, what's the first thing you would do to x? Go ahead, Morgan. Doesn't that undo the division by 2? Okay, and then you would subtract 7. Doesn't that undo that? And then divide by 3. So it's reversing the process. So when you look at, I'll tell you what kids do. And I'm just going to get ahead of this now because it drives me absolutely bonkers. Because we're going to be doing this, like I said, all year long. If that's the function, if it's a multiple choice and it says which of the following is the inverse, this is what they'll pick. Because they just want it to they just flip all the signs. Not everybody, but there's enough that it drives me bonkers. Where they'll just flip the sign and say that's the inverse. They're kind of missing the boat there, right? So it's usually not going to be that clear of just an opposite situation. It's almost never going to be. In fact, you probably want to stay away from that option if it looks too obvious. You have to kind of think about, if you're going to think about it, you want to think about it the way that we just did over here, going through the order of operations on the one and seeing how the order of operations on the other reverses that process. Okay? Obviously, there's a way to physically do it, and that is just by making sure that f of g of 3 gives you 3. So if I look at g of 3, 2 times 3 is 6, minus 7 is negative 1, divided by 3 is negative 1/3. So g of 3 is negative 1/3. And then if I plug negative 1/3 into f, 3 times negative 1/3 is negative 1, plus 7 gets me to 6. 6 divided by 2 puts me back at 3. So f of g of 3 is 3. Now, there are cases where that could happen coincidentally, yet they're not inverses. So what actually also definitely has to be true is that the opposite order of the composition, so rather than f of g, g of f of that number would also have to work. And if that happens both directions, they're definitely inverses. So g of f of 3, f of 3 is, 3 times 3 is 9, 9 plus 7 is 16, 16 divided by 2 is 8. So we have g of 8. And then plug in your 8, 2 times 8 is 16, 16 minus 7 is 9, 9 divided by 3 is 3. So we are good. And once you know their inverses, save yourself the time. What's f of g of negative 2, Alexa? Negative 2. What's g of f of 11, Owen? 11. Okay? Underneath that, I put a little asterisk next to it. It's a key point in a different kind of presentation. If two functions are inverses of each other, then point AB on one of the functions will kind of map to a BA on the other function. So for example, if f of x contains the point, let's see what, f of x, when we plugged in 3, we got 8. So if f of x contains 3, 8, then g of x contains 8, 3 is what we're saying there. Does that make sense? Does anybody know what transformation that is? If 3, 8 maps to 8, 3? Yep. Reflection, yes, over what? I'll give you 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's 3, 8. And then 8, 3 would be around there-ish. So this gets to this. Reflection over, Bella?
Is it the y equals x line?
Very good. That perfect diagonal line, y equals x. Nice job. Okay? More to come on that because that's like a third feature of inverses that's important. So in exercise 2, take a minute, read it, and think about your answer, then we'll take a vote. So on the count of 3, I want you to hold up 1, 2, 3, or 4. On your mark, get set, go. I see mostly 3s, a couple 2s, which I think with the they both flip-flop the numbers. The answer is 3. 2, maybe it just happened from not looking carefully enough, or maybe you just need to know that you do not also switch the signs. -3, 5 becomes 5, -3. Okay? All right. Notation. So a lot of times they won't actually use the word inverse. Okay? They'll say, here's your function f of x, and they'll tell you what it is. And they'll say, what is f? And it looks like to the negative first power of x. It's not an exponent. It's just the notation that means the inverse of f of x. Okay? So, in other words, now that we know these two are already inverses, they could have, instead of using a totally separate g of x, they could have and probably will refer to that second function as f inverse of x. And that's how you would read that. We don't actually say f to the negative first power because it's not a power. It's f inverse of x when you read that. Okay? So, as we see these throughout the year, you won't always see the word inverse. You just have to know this notation means the inverse of the f of x function. So, here's a big process that you essentially have to memorize. Have you guys ever done inverses before? No, this is all brand new. Okay. A fairly easy process, but just trying to get used to it here. They'll give you the function. They'll ask you to write your own inverse. Now, kind of with the logical process that I shared with you above, you might be able to think through it. Because here you first multiply by 3 and then subtract 5. So what would be the first thing you have to do in the inverse? Lucas? Add 5 and then Bella? Divide by 3. So if you understand that logical piece that we did up there, you actually could do it, but this is an easy enough process to do and memorize and just get through, because it won't always be that easy to unravel in your head. So first step, let's make the f of x a y. So on the original function, rather than keeping it in f of x for a moment, we're just going to change it to y equals, which really means the same thing. And then you flip-flop the x's and the y's. X equals 3y minus 5. For the record, doing that right there, that flip-flopping of the x's and the y's, is very much tied to this idea, where you're just flip-flopping the points. Yes? So that -3, 5 that became 5, -3, the AB that became BA, that's really what that part is. And then you just solve for y, so I'm going to add the 5 over. And there's where you see that unraveling. If the last thing you do was subtract 5, that's the first thing we undo when we're solving. And then we divide both sides by 3. And we get y equals x plus 5 over 3. And then we just have to clean up our notation. So rather than y equals, we're going to go back to f inverse of x equals x plus 5 over 3. Okay, simple enough. Okay. So, a special type of function. So, first of all, you know a function is something that the x value cannot repeat, right? And if you're looking at it visually, it has to pass the vertical line test, right? Okay. Additionally, there's like a more special type of function called a one-to-one function. So highlight that, circle that. What a one-to-one function is obviously first and foremost, it itself has to be a function. But secondly, its inverse also has to still be a function. Okay, sometimes the inverses are functions, sometimes they're not. If the inverse is also a function, then we refer to it as a one-to-one function. So what that means in like tests kind of comparable to the vertical line is that in a one-to-one function, this special type of function, you not only pass the vertical line test, but you also pass a horizontal line test. Okay, so you pass both of those. So here's something. This is a function because it passes the vertical line test, but it is not going to be a one-to-one function because it fails the horizontal. Versus if I just take a line, like a linear function, this is obviously a function because it's passing the vertical line test, and it's also passing the horizontal line test, which means that a linear is a one-to-one function. And then as far as looking at tables of values, you know that in a function, no x-coordinate can repeat itself. If it's going to be a one-to-one function, we add on the fact that no y-coordinate. You know what I mean by domain and range, right? Domain is your x-coordinates, range is your y-coordinates. So with normal functions, no x value can repeat itself. With more special functions, the y-coordinates don't repeat themselves either. So based on that, part B particularly, take a minute to look at your 4 options there, and one of them is a one-to-one function. Thank you. Where'd you find it?
The bathroom.
The boys' bathroom?
Yeah, it's on the ground. Difficult.
Unbelievable. Thank you. Take a minute based on this, and obviously go back and read as much as you need to. Pick which one you think is the one-to-one function, and we'll take a little vote again. Okay, so we're looking for which one is a one-to-one function. On your mark, get set, go. You guys are too good to be true. It is 3. Obviously in this one, that's not even a function. This one's a function, but it's not one-to-one. And then on 4, this one's a function, that's fine, but again the 10s repeat, so it's not a one-to-one, so we're just 3. How about exercise 4, looking at graphs and deciding which one is a one-to-one function. So take 30 seconds to look at those and choose your answer. On your mark, get set, go. 3 it is. This one fails vertical, not even a function. This one fails horizontal, so it's not a one-to-one. This one's good, passes both, and this one passes vertical, fails horizontal. Beautiful. Okay? All right. So in exercise 3, we're given the original function equation, and we're shown a picture of it. Use the graph to answer the question of what is f inverse of 2? Raise your hand when you think you have a guess as to what the answer is. Lucas, is that a hand? All right, I don't want to hear from you yet. Oh, Vince! What do you think? 6. Lucas, were you thinking 6 as well? 6 is correct. Vince, share with everybody else how you got that. You're not supposed, I didn't ask you to ask me a question. I asked you to tell them, because you got it right. So whatever you were thinking was correct. Right, so he figured it's not asking me for f of 2. If it was asking me for f of 2, then we would just go to 2 like we did, and the inverse wouldn't be an issue. But it's asking you for f inverse of 2. So the input of the inverse function is like the output of the original function. Yes? If something is going to be the input of the inverse function, then it's the equivalent to the output of the original function, where that whole thing kind of switches. So I don't know the best way to really show this other than, he kind of just said it. If, that's obviously the x coordinate of the inverse function, but since we're only looking at the original function, that's like the y coordinate. So he went to the y coordinate of 2 and figured out that that happened when x was 6. So let me just kind of write this differently so you can see that. If f of 6, and this is our f of x function, f of 6 is 2. So we all know, because we talked about this over the past couple days, that's the point on the original function 6, 2, which is going to equate to the point on the inverse function of 2, 6. So f inverse of 2 equals 6. Okie doke. Was anybody trying to write their own inverse function? And that's fine. Is that how you got 6? Okay. And that's absolutely a legit way. Write your own inverse function and then plug 2 into that. I only like what Vince did because it did say use its graph, and I want you to make that connection, but that's absolutely like a backup way. It's just a little longer. But obviously, I think that way kind of sits better with people. Vince was correct, but I'm not sure everyone's fully going to wrap their head around that. And then, so likewise, f inverse of -4 means that's to be our y coordinate on our original. So if I go to a y of -4, 1, 2, 3, 4, the x coordinate that pairs with that is -1, 2, 3. So the point on the inverse function is -4, -3, which means the original function contains -3, -4, which we do see. Okay? So that can get a little bit, messy when you're thinking about it. How about the y-intercept? Guess what? If the main piece of inverses is that you flip-flop the x and y coordinate, then the y-intercept of the inverse is going to be the same as the x-intercept of the original. Does that make sense? Because you're flip-flopping x's and y's. So the y-intercept of the inverse is going to be the same as the x-intercept of the original. And if I look at my original, because that's the picture I'm looking at, it's just at 3. So the y-intercept is going to be 3. Think about that visually. Look up at the graph for a second. This is the point 3, 0 on the original. I'm supposed to just flip-flop the points, right? So 3, 0 is going to become what, Chloe? 0, 3. 1, 2, 3. So it'll be right there. And let's just do one more so we can fully graph the inverse. Here's a point on the original 0, -2. If I flip-flop 0, -2, I get -2, 0. And if I just connect those, here's the original function. Oops. And here's the inverse. So the y-intercept of the original became the x-intercept of the inverse, and the x-intercept of the original became the y-intercept of the inverse. You notice how they share a point? What point is that? -5, -5-ish, right? Why do they share -5, -5? What's -5, -5 when you flip it? -5, -5. So they obviously both have that. So that was part C. And lastly here, we have a table of values for an original function. They're asking us to graph the inverse simply by switching those ordered pairs. So -2, 4 is going to become 4, -2. -1, 1 is going to become 1, -1. 0, 0 flipped will still be 0, 0. 1, 1 flipped will still be 1, 1. 2, 4 becomes 4, 2. Go ahead and plot those 5 points and connect them to make a new graph. You have 2 assignments coming back, right? Your regular homework and then Friday spiral. So always 2 things due on a Monday. I think there's 11 here. So make sure you get 2 sheets before you go. Game last night? Yeah. Did you? I was in bed by the time, so I was not. That's for me, but I just got done. If you didn't get 2 sheets, let me know. I might have counted off wrong.